Welcome to ClickMyProject.com. Our project title is the interactive augmentation of the visual evidence for the weekly supervised lesson, localization and deep interpretability frameworks, application to the color on this images. This is our abstract. Deep learning system interpretability is becoming more popular in the field of medical images in an effort to boost professionals' confidence in the prediction made and make it easier for them to be used in the clinical settings by enhancing visual evidence, which suggests a deep visualization technique to improve the interpretability of deep learning classification tasks in medical images. Suggested approach gradually reveals anomalies based on a classifier's predictions that was only trained using image level labels. A specific visual attribution approach is used to extract the initial visual evidence of the prediction of each image. Localization of the anomalies is made possible by this, and they are afterwards eliminated by selecting in painting. In our process, our main objective is to classify the retinal disease using the CNN-LSTM V3 model for training the images, as well as to know the symptoms and remedy for the particular disease predicted from the images. For the deep learning model, we have to find the accuracy and the loss of the algorithms, and also find the approaches to perform the accuracy model. This is our objective. Develop a retinal disease classifier. Develop a study material for the particular images, disease symptoms and remedy. Improve the accuracy. Use the one more deep learning. This is a system architecture. We have to import the image data set for the classification of the retinal images, and then move on to the next module is the pre-processing. We have to resize the all images and filtering the all images and splitting the images within for the training as well as the testing by the ratio of 8:2, and then extract the features. Next module is the feature extraction. Extract the features for the classification of the particular disease classes, and then in classification we have to implement the CNN-LSTM V3 model. It is a 48 layer of a inception V3 model, and then move on to the next one as the prediction. In prediction, we have to predict what type of disease of that images, and the next one is the performance analysis, accuracy and loss. And then this is our flow diagram. From our image data set, we have to select the data and pre-process it by some techniques, likewise resizing, segmentation and filtering, and then split the data by the training as well as testing. Feature extraction, likewise we have to separate the features of that all the diseases, and classification, CNN-LSTM V3 model, and then in prediction we have to predict the class of that disease, and then performance analysis, accuracy and loss. This is a use case diagram. From the user point of view, what are the steps we have to done in this process? First one is to select the data, pre-process it, split it and extract the features and classify it, performance analysis. And this is a ER diagram, a start point and load the data, and from the loading we have to select the data, pre-process it and split it, feature extract it and classification using the CNN-LSTM V3 model, and then performance analysis. We have to find the accuracy and the loss of the model what we are used for the classifying the multi-class disease. Sequence diagram. It has a 4 sequences: start, pre-processing and classification, performance. From the first sequence we have to load the data. Second sequence we have to pre-process by the filtering and the resizing, and also done the data splitting for the training as well as the testing data set. Third sequence is the classification, CNN inception with the model, and then performance analysis, accuracy and loss. After executing our main program, we have to classify the 10 classes of the diseases. 128 images, we have to train images and test images, and we have to epochs, we have to import the epochs and print the array of that images. After executing our main program, we move on to the app.py program. After executing using the anaconda prompt, we have to find that local host. From the local host, we have to draw like this. Here we have to upload a image. This is a glaucoma image, and we have to predict the glaucoma and symptom of this and the remedy for this. This is the overall process of our retinal classification disease classification.